Welcome to Study Loop.
Okay, super cool. So now we have this Robinson annulation reaction, in which we kind of have a cascade of two reactions occurring. So if we take these two and we subject it to hydroxide, this hydroxide is going to deprotonate the most acidic proton, which is of course this alpha proton, because there's two carbonyls adjacent. After this deprotonates, we can think of this as a nucleophilic carbon. That nucleophilic carbon is going to, of course, attack this Michael acceptor to form a carbon-carbon bond. You see it? This is the new bond which was formed. Now at this point, we can actually have some type of isomerization occur. So right now we have our enolate on this side, but this can wrap around after protonation and deprotonation. We can actually access this enolate. And when this enolate forms, this carbon can wrap around to attack the carbonyl. We'll then generate this six-membered ring, excuse me. The alkoxide in this position, and after a couple protonations and loss of water, it'll generate the unsaturation to regenerate an alpha-beta unsaturated system, but in a fused cycle. So this is the Robinson annulation. If we're to try to map out where our original atom came from, so we have 1, 2, 3, 4. This carbonyl is actually now here. So if you notice, the double bond that was formed is from this carbon, and the original unsaturation is lost. You can keep this in mind in order to kind of shortcut future reactions. Also note that this carbonyl is completely lost as water. Did you get all that? Okay. Let's try to do the next couple a little bit faster and predict what the products are going to be without drawing the full mechanism. So here we have our alpha-beta unsaturated system, as well as this cyclic ketone. So of course this is going to be the nucleophile to attack this position, open up, and then finally this carbon is going to be another nucleophile to attack and open up and eventually lose water. So our end product is going to be a double bond which forms at this position to our carbonyl, single bond which forms here. We still have a methyl group hanging off. That's the answer to, oops, I kind of shortcutted that, my mistake. That was C. Great, let's go to B. We have the same Michael acceptor as the first reaction. And we have this acting as a nucleophile. So again, this carbon will attack the Michael acceptor. This will come up and around, back around, and then this carbon will attack that carbonyl. So if you can't see that directly, we'll have this bond forming here, and a double bond forming at that position. And again, here is our original Michael acceptor in the annulation reaction. Finally, we have this nucleophile reacting with the same Michael acceptor. So this carbon will attack at this position. Oops, that's my mistake. It will actually attack at the Michael acceptor position. So it'll come back around to attack that carbonyl. Eventually you're going to lose water to form the unsaturation. And here we have the final product of this annulation.